Welcome to another part of the Physics Points to Spirituality series. In the book Tao Te Ching, written by the well-known spiritual teacher Laozi before the Common Era, it is written, "There was something formless and perfect before the universe was born. It is serene, empty, solitary, unchanging, infinite, eternally present. It is the mother of the universe. For lack of a better name, I call it the Tao."
This corresponds to the currently most widely accepted physical description of the origin of the universe, the Big Bang Theory. In the first part of this series, it is explained that Tao manifested itself during the Big Bang as the energy of the universe. Most physicists believe the universe was born in a Big Bang, 13.8 billion years ago. In it, the energy making up everything in the cosmos we see today was squeezed inside an inconceivably small space, far tinier than a grain of sand, or even an atom. Then, this unimaginably hot and dense universe expanded faster than the speed of light for a fraction of a second, a period called cosmic inflation. First to take shape were subatomic particles, like quarks, then bigger particles, like protons and neutrons.
About 1/100th of a second after its origin, the universe had cooled to several hundred billion degrees Celsius, below the threshold temperature for all heavy particles. At that time, the universe was filled with an undifferentiated mixture of matter and radiation. Every particle, including neutrinos and antineutrinos, was colliding violently with other particles. Despite the rapid expansion, the universe was likely in a state close to thermodynamic equilibrium. The energy density of the universe at that moment was around 21 times 10 to the 47th electron volts per cubic meter, equivalent to a mass density of about 3.8 times 10 to the 12th kilograms per cubic meter, about 3.8 billion times greater than the density of water on Earth. The universe was expanding so rapidly that it grew by approximately 1% in just 0.0002 seconds. At this stage, there were very few nucleons, only about one proton or neutron for every billion photons, electrons, or neutrinos. There were approximately equal numbers of electrons and positrons and roughly equal numbers of neutrinos and antineutrinos. Atomic nuclei did not yet exist. The circumference of the universe may have been around 1.2 parsecs at that time. 1 parsec is approximately 3 times 10 to the 16 meters, or about 3.3 light years.
At approximately 0.12 seconds, the universe had a temperature of around 30 billion degrees Celsius. The universe was still dominated by electrons, positrons, neutrinos, antineutrinos, and photons, all in thermodynamic equilibrium. The energy density had already dropped to only about 3 times 10 to the 7th times greater than the rest energy density of ordinary water. The time required for the universe to expand by 1% had increased tenfold, meaning the expansion had slowed down, primarily due to gravity. Atomic nuclei still had not formed. Protons and neutrons were still relatively scarce, with neutrons making up about 38% of all nucleons and protons about 62%. At approximately 1.10 seconds, the universe had a temperature of around 10 billion degrees Celsius. Neutrinos and antineutrinos began behaving as free particles, meaning they were no longer in thermodynamic equilibrium with electrons, positrons, and photons. The total energy density of the universe was equivalent to approximately 380,000 times the density of water. The time required for the universe to expand by 1% increased tenfold again to approximately 0.02 seconds. Electron-positron annihilation began to dominate over their creation from radiation. Atomic nuclei were still not stable. Of all nucleons, about 24% were neutrons and 76% were protons. At approximately 13.83 seconds, the temperature of the universe was around 3 billion degrees Celsius. Electrons and positrons were annihilating significantly faster than they were being created, so their numbers rapidly decreased. The energy released by this annihilation slowed down the cooling rate of the universe. As a result, neutrinos had become about 8% cooler than electrons, positrons, and photons. From this point on, the temperature of the universe is no longer uniquely defined, so I will refer to it as the photon temperature. Stable helium-4 nuclei also began to form. Of all nucleons, about 17% were neutrons and 83% were protons. At approximately 3 minutes and 2 seconds, the temperature of the universe was around 1 billion degrees Celsius. Electrons and positrons had rapidly decreased in number, and the main components of the universe were photons, neutrinos, and antineutrinos. The neutrino temperature was approximately 35% higher than the photon temperature. Stable nuclei of tritium and helium-3 also began to form. Of all nucleons, only about 14% were neutrons and 86% were protons. At approximately 3 minutes and 46 seconds, the temperature of the universe was around 900 million degrees Celsius. The synthesis of many atomic nuclei was taking place. But after 20 minutes, the universe was no longer hot enough for nuclear fusion. What was left was a hot, cloudy soup of electrons, hydrogen, and helium nuclei. This stage lasted for about 380,000 years. At approximately 34 minutes and 40 seconds, the photon temperature was about 40.1% higher than the neutrino temperature. The energy density of the universe had already dropped to about 9.9% of the rest energy density of water. At around 700,000 years, the cosmos had cooled enough for electrons to combine with nuclei and form the first atoms. The shortage of free electrons made the universe transparent to radiation, and the coupling between matter and radiation was gradually broken. Over the following hundreds of millions of years, this allowed the formation of stars and galaxies. The universe as we know it today formed even later. Our sun formed at around 9.2 billion years after the Big Bang, and Earth formed at around 9.26 billion years, roughly 4.54 billion years ago. Today, the universe may have a circumference of approximately 40 billion parsecs, and its temperature is about 3 Kelvin. Another statement in the book Tao Te Ching is, since before time and space were, the Tao is. If we connect this with the previous quote, it is exactly what modern physics describes. Space and time themselves emerged together with the universe. Before the formation of our universe, space and time did not exist. Or the next sentences, the Tao gives birth to 1. 1 gives birth to 2. 2 gives birth to 3. 3 gives birth to all things. This also matches the Big Bang theory, because at first there were only a few types of particles, which after cooling began to form atoms, and later billions of different forms of matter. How can physicists learn anything about the origin of the universe? In the book Tao Te Ching, it is written, "To find the origin, trace back the manifestations." And since manifestations correspond to present-day matter, this is exactly what physicists have done to learn as much as possible about the origin of the universe and its earliest stages. They began accelerating particles in particle accelerators in order to study processes at increasingly higher energies, meaning processes that existed in increasingly earlier phases of the universe. The higher the energy of colliding particles and accelerators, the further back in cosmic history such processes likely occurred, because the energy density of the universe, and therefore also the energy of particle collisions, decreased over time. What supports the Big Bang theory in physics? First of all, it is general relativity. Alexander Friedman found that relativity naturally describes a cosmos that is either expanding or shrinking. One possibility he considered was that everything we observe today expanded from a single, infinitely dense point. Published in 1922, Friedman's work was largely ignored. 5 years later, history repeated itself. Belgian priest and astronomer Georges Lemaître did the maths again and concluded that our universe mushroomed from a primeval atom. Just like Friedman, Lemaître was ignored. Albert Einstein later admitted that he knew his equations indicated that the universe must be either expanding or contracting when he wrote them.
Then there is the cosmic microwave background radiation. In 1964, physicist Robert Dicke interpreted the hum in his supersensitive energy from the universe's birth that covers the entire cosmos. A faint relic glow from 380,000 years after the Big Bang. It's the furthest back we can see with light. The expansion of our universe can also be observed, as demonstrated first by Georges Lemaître and then by Edwin Hubble and others.
The Big Bang Theory does not prove the Tao Te Ching, but it does point in a similar direction. My prediction is that the more we learn about the origin of our universe, the more it will align with spiritual teachings such as the Tao Te Ching.
Write in the comments what you think about this.